Hey everyone, hope you're all doing well. We got a fun crowd here. Try and get the energy back up. I'm excited to have this panel today because it is literally 3 companies that are post-revenue, that have real Web 2 users and use cases that aren't just like these small projects, but actually have like meaningful traction. And that's really fucking cool in the blockchain space, let alone in the blockchain AI space. So quickly, we've got Trevor Koverko from Sapien, Jeremy Hazan from Hyperbolic, Jonathan Jaranilla from Exabits. Let's get started by having you guys kind of quickly just go through, maybe give like a one-line overview of your project and like some statistics on actual usage.
Yeah, thanks, Gil, and everybody. It's great to be here with so many builders. My entry into AI was very... Does that work better? There we go. So I'm friends with one of the co-founders of Scale AI, and we were chatting, and I said, hey, I've got a kind of a silly question. Is it true most of the data you produce, they call themselves a data foundry, they produce data, you hear like chip foundries, well, data is the new bottleneck in AI, so they need their own production facilities. And they have these huge centralized facilities with real humans in these kind of call centers, and it is shocking how much scale these things, how much the AI data sets rely on these massive amounts of humans. We call it industrial scale RLHF. And that's really one of the reasons OpenAI leapfrogged over the early models. They weren't the first, they were just the first one to put millions of humans in the data sets, fine-tuning them and structuring them. And so we started out with a question like, hey, maybe, can we decentralize this? Like maybe we could have people just from their Android phones producing data, and you wouldn't need to have it all in one place. And the obvious benefits of that, you get like more specialized humans and you get a little more efficiency. So that was the beginning of Sapien, just being, hey, we want to be the biggest network of human data labelers. We like to think of ourselves as a frontier data company. We're trying to produce new data, and humans are actually really uniquely qualified to produce new data, especially expert humans that have like domain-specific knowledge that these models don't have yet. It's kind of funny because right now the machines need humans more than the humans need the machines. The machines are plateauing in their performance a little bit, and the only way to break through this data wall, by the way, which is a real thing, all of the open internet data has been fully mined multiple times over. And so where's the next frontier? Is it going to be asking JP Morgan to access their 120 petabytes of on-prem data? They're not going to give access. That's their only post-AI world competitive advantage. Is it going to be licensing it from Reddit? Well, it's going to be expensive. So the other categories, you're going to have to create your own data. Sorry, this is dragging on a bit. You're going to have to produce your own data, and we're trying to make it easy for anyone who needs new data to rely on expert humans to do so.
Can you just give me like super fast stats, like how many human labelers do you have? How many things have been labeled?
We've done 2 million tags so far. We're still about a year old, so early stage. We have 100,000 unique labelers from around the world across dozens of verticals. We have Mandarin-speaking mathematicians labeling MathGPT data for a large public Chinese company. We work with other enterprise customers that pay us, so we have like a two-sided marketplace. So on the demand side, it's companies like Baidu, Alibaba, Midjourney. And on the supply side, we have about 100,000 labelers from 100 different countries doing the data labeling. And one last point is diversity matters. If you have a homogeneous group of data producers, or AI workers as we call them, you get kind of poor quality data outputs because you get slanted and biased results. So the more broad range of data producers you can pull from produces better quality data. And lastly, just with the humans themselves, it's really interesting because now it's almost like this new form of gig work is emerging where you don't have to have a car to drive an Uber. You don't have to like drive a bicycle to DoorDash. You can just pull out your Android phone and sell your knowledge to these models on demand. So we're kind of seeing the formation of a really interesting new gig working economy for AI workers.
Awesome, sweet, thanks Trevor. Next, Jeremy.
Yeah, thank you for having me here. So Hyperbolic started, we're building decentralized AI infrastructure, focalizing on 3 core goals. Basically, goal number 1 is the GPU orchestration layer. Goal number 2 is verification. We need to be, in a trusted network of third-party nodes. And third eventually is privacy. And so things started when basically, the co-founders were in a situation where they wanted to get access to GPUs for research and for AI innovation, and basically going on AWS or GCP or Azure, or like the main cloud providers, was making it extremely hard for them to do so, because lots of waiting time, and if they had actually the chance to grasp their hands on it, the margins are so huge that actually it was complicated, and it's not the only ones in the space that felt like that. A lot of researchers all around the world, a lot of developers, and a lot of AI startups are in the same position. So that is the reason why they decided to create Hyperbolic to really solve this pain. Two core products on the GPU orchestration layer, and the first goal that we're tackling. One is being the GPU marketplace, connecting basically the suppliers of compute onto our network, and then providing this compute basically to the people who need it the most, as I described earlier. And then the second one is providing AI services layer. For now, we started with inference, and we're going to be developing fine-tuning as well soon. And then more in terms of like stats, we have now 20,000 registered users on our inference dashboard, which is really cool. We basically have processed over 1 billion tokens generated also on our inference dashboard, which is really nice. And I would say that these are the two interesting stats.
Sweet. So it sounds like the traction is really on the inference side of things.
It is only because we started on the inference dashboard before the GPU marketplace. We basically spent more time crafting the marketplace because we wanted to have a fully functional operating system that would make it extremely easy for suppliers of compute to actually connect their machines into our network. And we wanted to have something that was also like, robust and scalable. And that takes more time than just hosting the open source models and optimizing them.
Yeah, well, I mean, I didn't mean it as a bad thing. I think it's actually great.
No, for sure.
If the demand is actually in like Web 2 users that are going to be that have inference needs, and they're choosing to come to you for inference needs versus OpenAI and Claude and
Yes.
Anthropic, etc. Like that's great. So
And with that regards, like we're very much into a Web 2 kind of like strategy for this in terms of like market share and ARR, which is pretty fun.
Awesome. And last but not least, Jonathan.
Hey guys, thanks for having us. So I'm Jonathan, one of the 4 core members of Exabits, and we have well over 10 years of experience in crypto, but less on the degen side. We have even more years experience in building data centers. So we've built over 100 data centers in the past for enterprise companies and as well as independent data centers. And now we are leveraging that data center sort of supply to provide compute to them to decentralize AI and Web 2 and Web 3 companies. Another thing that is very unique to us is that not only we're supplying companies directly with compute, we're also supplying a bunch of our partners, a bunch of deep in compute players in the space. Hyperbolic being one of our customers, leveraging a bunch of our 4090s, Akash, Aether, Ionet, they all are powered in part by Exabits infrastructure.
Awesome. I'm going to go the opposite direction.
Oh yeah.
This time on the next question.
The other part I forgot to mention on this traction, right? So we're just about 6 months into generating revenue. So we started just introducing our product to the market immediately started hitting like 3,000, and then now we're doing well over 6 figures in monthly recurring revenue.
Awesome. So in the millions.
ARR, yes.
Oh, millions ARR monthly.
Monthly, well over 6 figures. Yeah.
Awesome. Cool. So again, let's start the reverse this time. Why are people choosing Exabits? What from a technical? I mean, first of all, you all have obviously all your Web 2 solutions, AWS, etc., Google Cloud. But more than that, you've got GPU marketplaces. There's Akash, there's Ionet, etc. Like, why are people, especially Web 2 people that don't necessarily care about crypto, choosing Exabits as a platform for GPU, like as a GPU marketplace and for GPU compute? And is there anything like at a technical level that you guys have built and innovated on that makes it like especially compelling?
Yeah, so first and foremost, we're friendly on cost, right? So if you measure us compared to the incumbents, 40 to 70%, we're cheaper than them on that level. And on the technology perspective, we've built a lot of middleware on top of the GPUs that sit on a bunch of these data centers. One of them being fault tolerance, one of them being ensuring that, okay, each GPU that we have on board working on a specific workload is as far as the performance and the time and speed that they use to transfer different data sets is consistent. So for example, if you have one 4090 and you have 5 4090s working together, we try to make sure that, okay, they all hit the parameter of transferring at least 25 gigabytes per second. And between those 5, they are not differentiated in speeds by as much as 3%. By keeping that sort of parameter and set of criteria between the GPUs, we ensure that, okay, we're consistent, we're stable, and we're fast, and that's something that the enterprise companies look at us on top of the speed, right? One thing that is also I like to highlight is, even though we were 20% more expensive than some other providers in the space, we were 2 times faster because we had a lot of these technologies implemented.
Awesome. So it's really like this optimization around like network, the network itself, consistency, like memory optimization, fault tolerance, etc.
Yes, yes.
Sweet. Jeremy?
Yeah, great question. So obviously, the cost is, as you mentioned, is a differentiator that we have, especially compared to centralized solutions that can basically apply huge margins because they have a lot of compute, and they basically are in a position where they can actually make it happen because the demand is still flocking in. On top of just cost, we wanted to make sure that actually we can provide things that are differentiating. So let's start first with like the inference side of things. Like on the inference dashboard, it's very competitive in the Web 2 world. Yeah. There are a lot of inference providers. So first we made the choice of hosting having only open source models. Because we think that open source is basically going to be outpacing at some point proprietary models. So that's like a real take that we took. And then I would say the second one is really trying to optimize the models as much as possible, having like basically low latency, high throughput, great developer experience, and also providing things that are rare to find in traditional inference providers. So for instance, we're serving all of our models in BF16 unquantized basically, which makes it actually much more precise than the traditional way of doing it in FP8. The second thing is we're also providing like text generation models, both instruct and base, and we also try to take advantage of the the perks of Web3 and the perks of having a token where everyone who's building an open source model is struggling to actually generate revenue. And so we're entering this route of revenue sharing economy with Web 2 builders, and for that we actually signed a partnership, for instance, with Black Forest Labs, the company that's behind Flux, and we're getting started actually with revenue sharing model with them.
Awesome. I like it. So it's this combination of, again, all of you guys essentially have like marketplaces. It's this value-added marketplace, both from a technological perspective as well as from a business model perspective. Yeah.
And really quickly, sorry, on the marketplace, the GPU marketplace side, what we also wanted to emphasize on is having a very easy onboarding process for the suppliers. As I mentioned before, we created our own operating system called Hyperdose, which is literally a 2-step process, less than a minute to get connected and plugged into our network. And then on the demand side, actually having also a very smooth process, actually trying to have it better than what AWS can offer, and making sure that it's extremely easy on demand to get connected to the GPU.
Awesome. I like the name Hyperdose. It sounds like something for tomorrow night. Trevor, curious, like from your perspective, like this is in essence you're creating these foundries. Where is why are people first of all choosing you guys over Scale AI or any of the other like Web 2 or Web 3 marketplaces, and like is there anything on the from a technical innovation side, from a process or foundry management side that you guys have done?
Yeah, we won the Midjourney contract from one of the big guys of data labeling because of the diversity reason, because in that particular use case, they were building a vertical enterprise model and they needed as diverse of a labeler network as possible. So just one group of 20,000, 28-year-old Filipino men in Manila, there's nothing wrong with that, but for that particular use case, it wasn't sufficient. But just to see kind of what it looks like, you can actually see the product. It's game.sapien.io. It's just a mobile web app. And the point is that we're trying to build a network effect. So the more labelers we have, the better quality data they produce. There are some edge cases, but that's the key here. So we want people, if it's like 5 minutes at a bus stop, you can label some data, you can get paid, or you can do it as a full-time gig work. And if we zoom out from there, we're actually seeing a lot of increased demand for specialized data production. So for example, V1 of this was kind of generalized data labeling. That's what Scale AI does really well. So it's like low pay, low skill. This is a stop sign. This is a baby. Let's sell this to self-driving computer vision neural nets. And those days are kind of being replaced by more specific requests for human experts. So now we need, so some of the folks that we work with, we have a pancreatic cancer researcher who's drawing bounding boxes around tumors and cancer cells. They like zoom in 1,000,000x on an MRI image. And so not anyone can do that. You need to be a specialized expert. Another use case, we're working with the largest education company in China, TAL, to do their math GPTs. They have $5 million contracts, one for algebra GPT, one for a calculus GPT. And we're seeing this like, it's like vertical SaaS, but now it's like vertical enterprise models where they're all creating their own specialized models. You'll see companies like Harvey, that's one of the biggest vertical enterprise models that's specifically for lawyers. So they can take an OpenAI data set, but it's not quite specific enough, and they need to go and find proprietary data from professional lawyers to make it really good.
How are you finding these like specialists? Because that's a very different set of users than like the general people that are going to be on their phone, even if they are like broadly spread around the world.
I said no. The first, when they're like, you need to bootstrap a network of Mandarin-speaking mathematicians, I was like, hell, like no way. But then they showed us the RFP, which was 2 orders of magnitude more per label than a specialized labeler. And then I'm like, okay, so now there's a margin here to make this work. It's actually a much better business. It's just a bit more messy to onboard it. Hello. Switch. Thanks. But this brings me to one other quick interesting point for decentralized AI data is we're struggling scaling that out because every single enterprise customer needs a custom module and they have custom data formats and custom modalities that they're looking to do. So we have to do like build custom integrations for every single one. And it actually kind of inspired us to do a new initiative, which we're releasing it as a public good. We call it AI 20, and it's just standardizing decentralized AI data to solve that problem. And if you look at the DAI stack, I look at it like a supply chain. So you kind of have data collection, decentralized companies like Grass, and then they send it to decentralized structuring companies, that's like Sapien, and then we send it to decentralized training companies, that's like Jensen or Ala at BitTensor, and then they send it to Neuraj at Ritual for inference, and then they send it back to us for fine tuning. So we're seeing this kind of like, we rely on each other. And there's a network effect with our own businesses, but then there's an ecosystem network effect that's probably even more important because everyone in Silicon Valley still laughs at us, decentralized AI. And we kind of have something to prove here. So we have I go to all these panels with the AI and we're all best friends because we're all like, no one's taking it serious. So we have to like work together as an industry. So yeah, that's like one of the initiatives is like making that happen. We did it, my last project, we did a ERC 1400, which was a standard for tokenization on Ethereum. And it was a big deal. We got Fabian Vogelsteller, the founder of ERC20, the 6 functions that make it up. And that, no one talks about it. That was the real inflection point for Ethereum. It was really messy until ERC20 was standardized. So I think every kind of vertical, it's important to have those standards.
I like it. So we need more standards and probably another protocol to coordinate between all the coordinating protocols within AI. But we're not there yet. First, we start with you guys that actually like create revenue, and then that creates demand, and then we can have another protocol. Jeremy, I was going to start with you on this one. So like decentralization obviously has inherent trust issues. How do you know that people are being honest, right? IONET is famous for people spoofing their actual GPUs for what they are, and Jonathan will want to hear how you guys tackle this later as well. So how do you handle trust decentralization within decentralization and making sure that people are actually like executing the inference honestly?
Yeah, great question.
ZKML is famously slow,
Yes.
optimistic, has its own issues. So yeah.
Yeah. So obviously, decentralization comes with a big cost, which is trust in the network. And so, when you just take the example of centralized, cloud companies like AWS, GCP, Azure, and all of the others, they basically rely on two things. They rely on legal contracts and they rely on reputation.
Right.
And for us, it's, when you're doing it in a very permissionless way, you need to have those solutions. So as you mentioned, there are some solutions like OPML, like ZKML, like consensus, etc. The problem is that it's a major, overhead. Computational overhead. OPML would be great at scalability, but not so good at security, and ZKML will be amazing at security, as we all know, but not so good in terms of scalability. So we needed to come up with a new solution in order to solve that problem. And so we thought about this for quite a while, and eventually came up with a solution called proof of sampling, which is maybe not overall the best one, but it's actually the best one for what we're doing for AI. It can be applied to many different use cases, proof of compute and proof of fine-tuning, proof of inference, proof of training, etc., etc. To go back to your example, let's say that I'm a compute provider on Hyperbolic. Let's say that you, Gil, are a user on Hyperbolic. I can be incentivized to cheat. I can be, you can type in a prompt, and I can be incentivized as the inference provider, to tell you that it's like a Llama 3.145B model, but in reality it's a small language model. So for this, proof of sampling is the solution, and the way it's functioning is, I can use an analogy. It's going to be easier for everyone to understand, the concept. Basically, we got inspired by the bus system in Switzerland. So I don't know if any one of you went to...
Buses in Switzerland.
Yeah, okay. Buses in Switzerland. Not very sexy, but at least... Exactly. And so the way that it's functioning is that when you enter a bus in Switzerland, you're going to be paying 4 to 5 Swiss francs with a very, very low probability of bumping into a controller. That being said, out of random, sometimes a controller can step in. And if you actually didn't get
the controller is like the cop person that checks your tickets.
Exactly. And so if you actually didn't get to pay for your tickets, the fine is going to be huge. We're talking in the hundreds of Swiss francs, if not in the thousands, actually so big that it's disincentivize any rational actor to cheat into the network. And this randomness process also makes it such that you're incentivized to actually pay for your tickets. So this is exactly how proof of sampling, exactly how proof of sampling is working. And there are also some other ways, basically, of applying it in different solutions. It can actually secure AVSs, so we're actually doing a lot of partnerships, announcement with Eigenlayer and a bunch of other protocols for AVS through proof of sampling.
Okay, so you're doing like random sampling of inference, for instance, to ensure that a specific request is being returned honestly. How do you handle the fact that inference often isn't deterministic and you're replicating basically what the inference response should be, but it wouldn't necessarily be the same regardless, even if they were honest?
Yeah, so that's the reason why, basically, ZKML is 100% secure. For sure, we are getting close to this 100%, but it's really trying to find the right amount of parameters and making sure that the asserter, who is basically completing the task, is going basically to submit the results to the orchestrator, and then the orchestrator will be basically taking the decision of passing a specific challenge that will then, if it goes through, if the orchestrator decides to pass the challenge, then validators will be running the results, and then we'll be comparing all of the different results from the validators and making sure that it's matching the one from the asserter, and if it does, then it's perfect, and if it doesn't, then the penalty will be huge, and it's really disincentivizing through crypto economic incentives.
So is that a one for one? It's kind of still this kind of a sample of consensus within validators, and probabilistically it'll be honest and people will get slashed basically.
Yeah, exactly. It's really this pure Nash equilibrium problem that under the right parameters is helping to solve this problem, in a huge amount of the cases. Obviously.
Awesome. Jonathan?
Yeah, this reminds me of one of the last questions one of our investors asked us was, are you going to ever open up contribution of compute to anyone? And then my short answer was no, and hell no. And then the next question he said in that email was why not? And then I basically said it just introduces a whole bunch of anomalies and throws a bunch of wrenches into your ecosystem, right? So for one, we've seen other protocols introduce decentralized compute. Anyone can contribute, and a lot with crypto, people are more incentivized to game that system, right? So with one of our partners who were supplying H100s and 4090s to before that, they were like, oh, we messed up already. Like, we can't go back and track all these IPs, which essentially made them stop with the farming system that they have, right? So we are earning about $100,000 a month in tokens up until they said, okay, this is not sustainable because there's no business coming in, and the suppliers of that compute is not consistent. It's not enterprise grade, right? So the fickleness of people trying to game the system and trying to provide whatever is part of just to reap the rewards of a token is not consistent for enterprise companies. So for us, we don't have that problem just yet, and I don't think we'll have that problem in the near future because of where we are leveraging our supply from, which is from data centers, right? So we know all these data centers, we have relationships, we help build these data centers, and what that means is there's a lot of reciprocity and a lot of integrity that we have from getting these supplies, right? So it's with their mandate for these data centers to provide the best service, and if in the event that you do open up, there's a lot of things that you can do in Web3, right? Staking and slashing is one of them, reputation is another one of them, and also creating like a check and balance system through token mechanisms. I think that would be a really good way to design a ecosystem. Other people have nodes and checker systems.
Gotcha. Okay, so you're permissionless on the demand side, but on the supply side, you're still permissioned, so you're not going to run into issues like potentially a Kasha and IONET might have of like bad malicious actors. At some point in the future, if you choose to go permissionless on the supply side, then you'd use a number of incentives potentially.
Yes. Fortunately, while everyone sees that there is a backlog in GPUs, from our sense, we see that there's an abundance that we can service the market and just build many things on top of them as far as the hardware, acceleration, and middleware to make sure that, okay, even if the 4090s are not as popular, we can still make them useful to the network.
Yeah. And then last but not least, Trevor, how do you handle like quality, honesty, and like the variability of capabilities that a labeler might have, especially if you start going into these specialist labels?
Yeah, that is the question. When we started,
Musical microphones.
When we started, we had one hypothesis, which still hasn't been fully proven yet, which was, can one maintain quality of labels from humans in a distributed model? That is an open question. Scale AI says no, you need centralized control, you need top-down kind of hierarchical human spot checks and other incentives like we're going to pay you 3 weeks after the end of the contract because we'll give you retroactive pay deductions if our human spot checker said your quality wasn't good. Extremely inefficient. But how else do you do it? So we set out to kind of solve that problem, and we failed for a long time because it is hard. It's a Sybil problem. Like, how do you prevent people from just faking it? And so we started out doing more traditional things for decentralized QA and data labels. So we did things like anomaly detection or mean reversion stuff, where we would do a distribution curve, give the same question to 1,000 labelers, and kind of like plot out who we think is cheating. And so we were starting to get our kind of accuracy slowly was creeping up. Scale AI, don't quote me on this, but I think they're like 9 out of 10, 9.5 out of 10 accurate in their centralized model. And we could kind of get up to like 7 out of 10, 8 out of 10. And then quite recently, we started experimenting with Web3 incentives. So to your point on the supply side, staking, where people actually have skin in the game. We incentivize them to stake, so you don't have to, but if you want more rewards, you can buy the native token and stake. We don't have a native token yet, but like on testnet. And then you get more rewards, but if you start Sybil attacking, or if you're a bot, or if you're not playing in a genuine way and we detect it, you get slashed. And we didn't even really slash anyone, we just kind of threatened to. And holy shit, it was like 3 or 4 standard deviations, like improvement in quality. And so it's encouraging us that we might be, barking up the right tree, that we just, a weighted average of clever algorithms and incentives, we can kind of slay the big distributed QA dragon. And if we can, it kind of is disruptive, because if we're cheaper for the customer because we don't have to pay for all these facilities, and we can pay the labeler more, and the product is better as well, like, why would all this $10 billion infrastructure need to exist at all? It can all be replaced in a kind of first principles way.
I like it. Crypto economic incentives. Great. All right, we have 30 seconds left. I'm going to ask, give me 1 or 2 words for what you think is the most exciting thing in crypto AI that will be real in 12 months.
I think what I saw with PINAI do, hopefully that comes about.
Awesome. Jeremy?
I think that it's gonna help solve the problem of economy, like the economy of AI, basically.
Okay, gotcha. Cool.
Yeah, in our lane, it's solving this data wall is a giant problem across the industry. So if AI can help produce better quality frontier data, that'd be pretty cool.
Awesome. Guys, thank you. It was a ton of fun. And that's time.